Hello friends, welcome to GoodTecher LeetCode tutorial. Here, this time, we are going to solve unique path 2 coding problem. So unique path 2 is a follow-up question for unique path 1. You may have seen this unique path 1 coding problem before. So a robot is located at the top left corner of a m multiplied n grid, and robot can only move either down or right at any point in time. So robot needs to reach to the bottom right corner of the grid, and we need to calculate like how many possible unique paths to reach to the bottom right. Also, like a GoodTecher already have a tutorial on this unique path 1 coding problem. You can take a look at. And for this unique path 2 here, there's a slight difference. So now consider if there are some obstacles are added to the grid. So how many unique paths would there be to reach to the bottom right square? So like an obstacle and empty space is marked as 1 and 0 respectively in the grid. For example, if there is a one obstacle in the middle of a 3 multiplied 3 as illustrated below. So here we have this two-dimensional array, and there are like 3 rows we see here. The first row, they are all empty spaces, and second row, the second element is 1, so there's one obstacle, and third row is all empty spaces. So the total number unique paths here we see is 2. You can from either go down first and go right, or go right first and go down. So here, note here, m and n will be at most 100. So here, let's look at this unique path 2 coding problem, and it's also a typical coding problem about dynamic programming. And use dynamic programming technique that we need to calculate like when the robot reach to the each space, like how many unique paths to reach to that space, and then we calculate each square, each space, how many unique paths to reach there, and we get the answer of the how many unique paths to reach to the bottom right space. So here, let's look at the illustration. So here, suppose we have a robot, and we will have like a 3 multiplied by 4 grid. So 3 multiplied by 4 grid would be look like this. So there are 3 rows and 4 columns. 3 rows and 4 columns. So here we can put some random obstacle here. So like if 0, that means empty space, empty space, empty space. And we can have some obstacles as indicated by 1, 1. So all other places, so there are 3 obstacles, and all other places just empty space. So robot from the top left here, and the robot needs to reach to the bottom right. So we can simulate this robot's movement, like the robot can only move right and or move down. So like if we simulate the robot movement, like we can calculate like when robot visited each square, like how many unique paths to reach to that square, and then we can generalize a conclusion that how many unique paths to reach to the final n square. So here, let's simulate this process. So robot at the beginning makes the first move. So that's the first square, that's only one unique path because that's the first move. And the robot can choose to go right or go down. If the robot chooses to go right, there's still only one places because that's this is the first place you can only go from the first square to this square. That's only one place. And robot, if the robot wants to keep go right, and here the robot will encounter an obstacle. So this obstacle, we can just store the value 0 for this square. There's 0 unique paths to reach here, and also this obstacle breaks way to the next square. There's only 0 way to reach here because the previous obstacle already blocks away. Similarly, like here, if a robot go down and there's one obstacle we see here, so that's only there's no way to reach through there, and this obstacle also blocks the rest square for on this first column, so there's a 0. And the robot can only reach to this second square at the second row from this go right and go down this way. There's only one way, because from the left there's only 0 way, so there's only one way to reach here. And also similarly for this one, there's only one way, because from left it's just 0 unique path to reach there. And the robot, if at this second row, second square, the robot wants to go right, but here there's another obstacle. So this obstacle we can stop here. That's a 0 way to go there. So the robot can only go from this second square to go down and keep go right. Keep go right, there's only one way, because from left there's one way. From top there's a 0 way, that's blocked. Also, like this square, from the left or right, both the 0. There's no way to reach that. So this square, there's no unique path to reach there. And the robot can only reach the final square by one unique path, because from top is a 0. So the only way is first to go right and go down, and go right to reach that. So we can get some conclusion here. So like we see that first row and the first column, there are some similarities. So like a first row, if everything is empty space, every square that with the unique path to reach to there is just 1, because you can only go one way, that goes straight down to reach to each square. Similarly, for each column, the first column square, to visit each square, there's only if everything is empty very smoothly, and that's just one unique path to reach there. So that we know, like we have a unique path that's 0j. This will indicate the first row. So that will be if there's an obstacle as a low unique path, and also break the rest way to reach to the rest square, and otherwise there's only one unique path to reach there. And similarly for the first column, that will be like this. That's every first elements in each row. So if there's an obstacle encounter, that square would be just 0. Also break the rest square. Otherwise, it would be one unique path. And second, if we see like those square not in the first row or not in the first column, those square, the unique path to reach there, we can just simply do a simple math. That's the total sum of the unique path to the left square and the total passes to the above square. So that would be the total passes from its left square plus total passes from its above square. We see like this one. This square, the unique path of this to this square would be the total unique path to its left square and total path of its above square. They are summed together. We get the unique path to reach to this square. Okay, we get the conclusion about how to calculate the unique path to visit each square in the grid. Like when we calculate all the square, each unique path to each square, and we will get the value, like even the bottom right square, how many unique paths to reach there. Okay, here, now let's go back to the coding to solve this coding problem. So I demonstrate in Java. So first, have some edge cases check. So if obstacle grid, this two-dimensional array is null, or if this obstacle grid is empty array, or if this obstacle grid, like each row there's no element, and we can simply return 0. So 0 unique path to reach to there. And then first, let's have two variable, that's height and width. So height is obstacle grid dot length, like how many rows, and the width is obstacle grid, like a first row, the how many elements, that's width, so how many columns. And we will initialize a two-dimensional array, it's called passes, to calculate how many unique paths to each, or to visit each square, each space in this grid. So that's the same size as this obstacle grid. So that would be height and width. So as we just said, for the first row or first column, we can handle differently. So like we can handle the first column first. So for first column, and every passes, if that's not an obstacle, would be 1. Otherwise, we can just break the. So if obstacle grid I is not equal to 1, that's an empty space, so the path would be 1. Because by default, when we initialize this two-dimensional array, each element would set to the value 0. So here, if the obstacle is not this obstacle grid at this place is not 1, so that's not an obstacle. So we can change the value to 1. That's a 1 unique path to there. Otherwise, just break. That means we encounter our obstacle, we can break this way. So the rest of element, the rest of space in the first column will just be set to 0. Similarly, for the first row, if the obstacle grid is not an obstacle at this place, so we can set this passes to 1, else just break. That means the rest space in the first row would have no unique path to reach to there. And for like other space, so here we can have a list loop here. So for int start from I and let's then height I++ for int j start from 1, j is smaller than the weight j++. So if that obstacle grade is not an obstacle, if that's not an obstacle, the unique path, as we just mentioned, would be the sum from its above square unique path plus is left, how many unique paths to its left square space. Otherwise, it's just a 0. Otherwise, that's just a 0. And we don't need to update here because by default it's just a 0. So here we can at the last return this. So for the bottom right, we need to get how many unique paths to the bottom right. So that would be simply the last element in the two-dimensional array, and be height -1, so length -1, and width -1. Okay, let's first do a quick check if there are typos before we submit. So if obstacle grade, we do the edge case check first. Obstacle grade is null. Obstacle grade the length is 0. Obstacle, the first row is 0. No elements, we return 0. And we declare height and width, like indicate the how many columns, how many rows for this obstacle. And we initialize these passes to indicate how many unique paths to reach to the each square. And for the first column and first row, we do spatial handling. So like an obstacle grade, that's not an obstacle. We add this value plus a unique path. We know that's just 1. Otherwise, we just break the row, because if ever encounter an obstacle at the first column or first row, the rest of the square cannot be reached. And for other space, and we do obstacle I, j. If that's not obstacle, it's just simply mass from its above square, how many unique paths to there, add with how many unique paths to reach to its left square space. And at the end, because we already calculate how many unique paths to visit each square in the grid, and we can simply return the last one. That's a unique path to reach to the grid, the bottom right grid. Okay, looks like we don't have any typos here, so let's click the submit button. Okay, that's beautiful. Accepted. We successfully submit the correct solution to solve this unique path 2 coding problem. Okay, so that's all about this unique path 2 coding problem, and thank you very much for watching GoodTecher LeetCode tutorial. I think that many friends come to my site and leave message say some thank you words. So I also feel grateful that from your support. With your support, I can do this tutorial better. So if you have any comments, any suggestions, or you want to see some tutorial about some which question on LeetCode, you can just leave comments here or leave comments on YouTube. Okay, so thank you for watching. Thank you for subscription. So see you next time. This is a GoodTecher.